Good morning, everyone. Today's lecture will focus on the exciting field of exoplanet discovery. Exoplanets, as you might know, are planets that orbit stars outside our solar system. Now, you might be wondering, how do we find these planets, often light years away? It's a fascinating process, and there are a couple of primary methods I'll discuss today. Alright, so, the first method is called the transit method. Imagine you're looking at a star, and a planet passes in front of it, like a tiny eclipse. This transit causes a slight dip in the star's brightness, and by carefully measuring these dips, astronomers can not only detect the presence of a planet, but also estimate its size. The larger the planet, the more light it blocks, and the bigger the dip in brightness. Now, that brings us to my next point, the radial velocity method. This method relies on the gravitational tug-of-war between a star and its orbiting planets. As a planet orbits a star, it causes the star to wobble slightly. This wobble creates a subtle shift in the star's light spectrum, which we can detect here on Earth. By analyzing these shifts, we can determine the planet's mass. The more massive the planet, the stronger the wobble. Keep in mind that finding exoplanets is incredibly challenging. These planets are incredibly far away and much smaller and fainter than their host stars. It's like trying to spot a firefly next to a spotlight from miles away. But despite these challenges, astronomers have discovered thousands of exoplanets, revealing a remarkable diversity of worlds beyond our own solar system. So, to wrap things up, the search for exoplanets is a testament to human ingenuity and our relentless curiosity about the universe.